All right, so today is Thursday, November 7th, 2019. I need to plug in my tablet so it actually starts working. We're talking about standard form today. So, quiet raise hand. Who wants to read the objective? It looks like Emma's first.
Graph from standard form and convert other forms of linear equations to standard form.
There it is. So not only will you be graphing down here on these two graphs, but you will also be giving an equation in slope-intercept form or point-slope form, and you need to convert it into this new form that you're learning today. So here's the general equation for standard form. ax plus by is equal to c, where a, b, and c are all just whole numbers. So I'm going to just point to all of these with an arrow. This b, this c, this a, these are all whole numbers. Is there a quiet raised hand that knows the more technical term for whole number that starts with I? Is there a quiet raised hand that knows it? Charles?
Integer.
Integer. So A, B, and C have to be integers.
That's 10 HP.
Yeah, cool. So I think if you can get the people that do the warm-up also, that would be super helpful. All right, so you'll notice that there's no slope here. And this is kind of the weird form where it doesn't have slope, but you can still graph it. While other problems, I always say first find the slope, then find some sort of intercept, or first slope, then some other point. This one, you just find 2 points. And the way that you do that is you find the x and y intercepts. You can see that if we're going to graph this, you need to find the x and y intercepts, and then you're going to make a line between those 2 points. Done. That's how you use standard form. So in order to find the x and y intercepts, let's review what you do. So I'm going to get 2 volunteers, one to do the first line, one to do the second line. To find the what intercept, I set what to what? Who has their card? Wyatt, you have your card?
Yes. Okay. Do you want me to do the x-intercept or y-intercept?
It's your choice.
Okay. To find the x-intercept, set y to 0.
Perfect, thank you. And I'll take your card. Next, Eamon.
To find the y-intercept, set x to 0.
There it is. So you set the opposite thing equal to 0. All right, so let's try it. Oh, don't hit someone, please. All right, so we're jumping down to example 1 now. We're going to find the x and y intercepts, and then we're going to make that line. So let's find the x-intercept first. So quiet raised hand, what am I doing? What am I doing? To find the x-intercept. Who has their card? Kira, do you have your card? Go for it, Kira.
So like to find the x. Oh, we already did this. To find the x, make the y next to the 5 a 0. Like put parentheses 5 times 0, and then negative 6x plus 5 times 0 equals 30, and then solve.
And then solve, yeah, perfect. So can someone else solve it for me? Who has a card that needs to get turned in? No one knows how to solve this thing? Ulysses?
So you like times 5 times 0, which will equal 0.
So yeah, just cross it out.
Okay.
Don't even worry about it. Perfect. Then next.
It's going to be negative 6x equals 30.
Perfect. And then
You divide negative 6 on both sides.
both sides by negative 6, and I get the negative 6 canceling out. And and then Ulysses, the final answer is
5.
careful.
Negative 5.
Negative 5. Perfect. So that is one of the things I'm going to need. I'm not going to box it because it's not my final answer, but it is an important piece of information. That means on the x-axis, I will graph negative 5. So the graph on the left, we're going to use for example 1. The graph on the right, we're going to use for example 2. So let's graph on the x-axis. Let's graph negative 5. So technically it's negative 5, 0. There it is. So you're going to make a point on the x-axis at negative 5. All right, I need to now do the y-intercept. Someone help me out. What am I doing first? To find the y-intercept. And you guys can go ahead of me. You don't have to wait for me. To find the y-intercept, Charles.
Make x 0, so negative 6 times 0 is 0, just cancel that out. And then 5y equals 30, do 5 divided by 30, which is 6. Then
I think you said it backwards, but yeah, you're good.
intercept is 6.
You have it indeed correct. The 5 cancels out, and y is equal to 6, which I'm going to circle. And still on the left-hand side of the graph, not the right graph, we're not using that yet, I'm going to make this point up here on the y-axis at 6. And then you're basically done. You're on step 2 now. Make a line between those 2 points. You're pulling out your rulers. You're making a line. I'll make mine in blue. Sure, why not? That goes through those 2 lines. Those 2 points, sorry. And that line should go on and on forever and ever. It shouldn't just be a line segment. It should be a line. Cool. And there is the line. It's negative 6x plus 5y is equal to 30.
Are we gonna find slope with this?
Yes, we are. Well, that's kind of a lie. We're going to kind of undo slope from this. All right, so what I want you guys to do is try example 2 by yourselves and use this right-hand graph to do example 2. Graph 9x minus 12y is equal to 36. I'm going to be walking around and making sure you guys are doing it right. Please check with your neighbors. Help them out if they need it. You can get some XP there. And if you want, you can try doing example 3 on your own. But we're going to come back together as a class to do example 3. And you guys are going to be definitely doing example 4 by yourselves. All right, good luck. All right, so I need 2 raised hands to tell me what to do. Who have I not called on for a while? Jade, yes.
Y is -3. Fine.
So how'd you get that?
I changed x to 0 first.
So that turned into 0. All right.
Then I just brought everything down, and then I divided both sides by -12. I got y equals -3.
All right, so I'm going to graph y equals -3. Another volunteer, the x-intercept now. We'll go with y again.
Yes. Okay. So to find the x-intercept, you're going to want to make the y next to the 12 zeros. So you have 9x minus 12 times 0 equals 36. We'll then cross out the -12 times 0, and then we'll have 9x is equal to 36, and then you divide by 9 on each side, which is 4. X equals 4.
And we're done, yeah. Nice. Thank you, guys. So I do this line.
How is it -3?
Ooh, good question. Someone else answer.
Ooh, can I answer it for her?
Let's give it to Larissa.
Because -12 is a negative, you're gonna also divide by -12.
All right. If there are no more questions on example 1 or 2, we're moving on to the next part. All right. So this is a little bit harder, yeah, because there's a lot of algebraic manipulation that you need to do. So we have an equation. Does anyone know what form this equation is in right now? Quiet raised hand. What form is this? You've seen it before. What is the name of that form? Charles?
Slope intercept form.
It isn't.
Y equals mx plus b.
Yep, y equals mx plus b, slope intercept, or the y-intercept form. Perfect. So I need to convert this to standard form. Again, standard form has to have integers in front of the x and y's, and you have to have whole numbers, integers, same word. All right, so the easiest way to do this is to multiply everything by the denominator. If I see the denominator is 4 and I multiply this y by 4, this 3/4 by 4, and this -3 by 4, that will get rid of the denominator and I will no longer have a fraction. That is my hint to you, my gift to you. If you multiply every single part by the denominator, it gets rid of the fractions. But you have to do it to every single part of the equation. Once I do that, my new equation becomes 4y is equal to 3x minus 12. I'll repeat that again. I'm looking at the denominator and I don't like fractions. I don't like fractions, so immediately I multiply by everything by what that denominator was, 4, 4, 4. You have to do it to every single part. 4 times y is 4y. 4 times 3/4, the 4's cancel out, and I'm just left with 3. And then 4 times -3 is -12. And then from there, you're just kind of rewriting it. So we need to move this 3x over. How am I going to do that? How am I going to move this 3x to the left-hand side here? What am I going to do? Jade?
Change y to 0.
Ooh, careful. So we're not going to actually change y to 0. We just need to move the 3x over. How do I move that over? Do I add, subtract, multiply something with the 3x? Subtract, exactly. And Kira, you have a question?
Yeah. Why do you need 3x on the other side?
So in order to get to this general form, the x has to be on the left-hand side, the y has to be on the left-hand side, and then the number, the constant term, should be on the right-hand side. Yeah, good question.
Oh.
Question, Charles.
What if you have multiple fractions?
If you have multiple fractions, so if I have a 5 and a 4, then multiply by 5 and 4, or by the least common factor of both, or the greatest common multiple of both of them. So you can multiply by things twice if you need to. Just multiply until the fractions disappear. All right, so after this, is it an answer?
I think there might be a teacher error. Is it supposed to be negative 12 on the equal sign when you choose one answer? Because that's a negative sign. No.
Actually, I made it purposely come out like that because I know that one of the Khan Academy homeworks, actually a few of them, come out with a positive 12. So we're going to have to somehow turn this into a positive 12. Yeah, so right now we get negative 3x, but it's good to see that. Yeah, plus 4y is equal to negative 12. And I see the same thing that Wyatt sees. Hey, that's not the answer. I have a negative 12 on the right-hand side. That can't happen. So what do we need to do to our equation so that the right-hand side is a positive 12? What do you got, Wyatt?
So to make it a positive 12, I think we just need to make it a positive 12 and then make it so, like on the other side of the equation, that would make that statement true. So I think instead of doing negative 3x plus 4y, would you do negative 3x minus 4y?
You'd be really close, but not quite. You can still get your XP. So every single time that I do some form of manipulation, I have to do the same thing to the right that I do to the left. Kira, talk to us.
If you take the negative off the 12, you have to take it off the 3, so it'd be 3x plus 4y equals 12.
Again, you are really, really close. You guys all have the correct intuition. You guys are in the right direction. But you can't just take off from the 3. You have to do it to every single one of these terms. So, Kira, can you revise your answer?
So, if you're switching the sign, like switching the 12 to a positive and 3 to a positive, you have to switch the positive 4y to a negative.
Exactly. And essentially what you're doing is you're multiplying every single term, or both sides, by negative 1. Which
it can never be a negative?
It could be a negative. It's just all of these answers are positive, so we have to switch the sign somehow. So, yeah, switch the sign of everything is the same thing as multiplying everything by negative 1. So our final answer is a positive 3x, switching the sign, minus 4y is equal to a positive 12. And which one is our answer? You guys can shout it out. D is the final answer. Nice. So you guys, on your own, try example 4. After you do example 4, check with a neighbor. Then you may begin on the homework assignment on Khan Academy. There are 2 assignments up. One assignment based on example 1 and 2, graphing, and one example based on example 3 and 4, where you have to rewrite it into standard form. All right, good luck. My hint to you for example 4 is maybe first you should distribute and then multiply by something. So first distribute the 2/5, you'll get some weird fractions happening, and then multiply every single term by a number. All right, good luck. A lot of people have been asking this question, like, can I just multiply everything by 5 at the beginning? And the answer is yes, if you're careful. Anything that's being added or subtracted, you need to multiply by 5 individually. So, for example, this y needs to be multiplied by 5. This negative 3 needs to be multiplied by 5. But the problem is, on the right-hand side here, it's already being multiplied by each other. So I don't need to do 5 times x, 5 times 7, and 5 times 2/5. They're all being multiplied together. So if I multiply just by one of them, just this 2/5 by 5, that's the same thing as saying this 5 is being multiplied by the 2/5, which is already being multiplied by this x plus 7. So if you just want to multiply at the very beginning, only multiply the thing out front. So that would be the shortcut, and then you'd get the equation 5y minus 15 is equal to 2 times x plus 7. This x plus 7 is already being multiplied by the 5 because the 5 is, like, all of this stuff is being multiplied already. The 5 is being multiplied by this x plus 7 by being multiplied by the 2/5. Another way of starting out this problem is doing this. Instead of multiplying by 5 right from the get-go, you do y minus 3. You don't touch anything, but you distribute the 2/5 to get 2x over 5 plus 14 over 5. You distribute the 2/5 first, and now that it looks very similar to the problem that we had up above, now each and every one of these 4 terms gets multiplied by 5. and you'll notice once I multiply everything by 5, you get something very similar. If I multiply everything by 5, I get 5y minus 15 is equal to 2x plus 14, which is exactly what's going to happen after I distribute the 2 into the x and then the 2 into the 7. So either way of approaching it, I'm going to call this approach number 1. I'll do this in black. Approach number 1 or approach number 2. Either way works as long as you're using the rules correctly. I feel that approach number 1 is more confusing because I feel like students always want to say, oh, I just multiply 5 by everything, which isn't always true. You multiply by 5 as many times as things are only being added or subtracted. Since these two terms are being multiplied, I only multiply the 5 once.